Alright, so let's see here. We need to do the AC testing on the transformer when the light goes out. And DC testing on the motor board circuits after it stops. So that's AC and that's DC. Okay, so let's see after it stops. When we have no lights on the buttons, but we do have the red light on the P1 relay. And the P1 relay is this one. So this is a cold start. Okay, so it went out. So the light is on there and there's no lights here. So we'll do AC test on the transformer. Get 116.8.9 and on the top it's 16.2. So again, that's 116.8.9, 117 on the bottom, and on the top it's 16.2. And then you said to do a DC test on the circuit board. That's showing minus 20.9, 21.1. So minus 21, minus 20.9 fluctuates. I don't know if these should be the other way or not, but let's try this. And when I do it that way, yeah, same thing, 20.9, although it's not a minus this time around. Okay, so what else do we need here? When you go up first thing, do your DC test in the motor speed control as you start. We just did that. Watch the DC voltage as you turn on the cam motor on and move the speed control dial. Watch the DC voltage. Okay, so that's on the board. So okay, so let's see. If it is that rectifier, it needs to cool down in order to start again. And if I can get it to see the light come on now. So if I can get this cam controller to run, I'll try to quickly put leads on it and see. I don't have the cam motor on yet, but it's showing 19.8, 19.9, so I'm going to slowly turn it up. And it clicks off, and it shows as 21.3. Try that again. I got 20.5. I'm going to turn on the cam control dial slowly. 17.5, 16.8, 16.6, 16.9, 17, and then it stops. And when it stops, this is the result. Okay. Once you lose the DC circuit, this is when I'd like you to run the AC voltage test on the transformer. Okay. So we lost the DC, so now I'm going to try the AC on the transformer. So it's 117.2.3, and up here it's 16.2. When you first start up the machine in the morning, everything is cold. It's like today. When you installed the cam motor on a bad blade the other day, it's most likely overheated the reactor, and now you're experiencing what is known as heat-induced fault. Okay, yeah. This basically means that the internal connections to the rectifier open up or short. Right, so the rectifier, hey, how are you? The rectifier is toast. So, yeah. I'm just going to try that again. I'll shut that off. P1 is off. P1 is on. I'll close these. Shut all that off. So the motor for the sharpener is on. The pump for the oil is on. $116. And on top it's 15.916. And on, gonna go with the DC for here. Hope I'm doing this right. So down on that little circuit board it's 19.7, 19.8. So I'm gonna leave those on there somehow. And then turn on this dial slowly. Right away it shut off. So, yeah. So I think you're right on that, Bryce. It's that rectifier is toast. So I'm gonna upload this video, show it to you, and see what you have to say. But yeah, likely what we're gonna have to do is swap out that board, and that should solve the problem. I might take you up on your offer too to fire the board down, and if you want to swap out that rectifier, then we'll give that a go and see if we can keep it as a spare. Alright, time to get busy.